These are standard cases. We should know theory behind the concepts and the end result. Once we know all these things and the end result, we can really save time in exams like JEE Main, NEET as well as CET, because most of level 1 questions or level 0 questions from JEE have started appearing in NEET as well as CET. So make sure that you learn all the steps and also try to remember the end result. If such questions appear in the exam, you don't have to work out. You can directly jump into the answer. You have understood the problem, you can remember the answer. First, let me explain the problem, not solution. Problem. After that, the answer. After that, the explanation. Let's start. Two charges each equal to Q and are kept at x equal to minus a and a on the x-axis. Done. So, x-axis, y-axis, origin, this is minus a and this is a. Done. There is Q, there is Q. A particle of mass m and charge Q0 equal to Q by 2 is placed at the origin. Here is the particle. If Q0 is given small displacement along the y-axis, Q0 is given small displacement along y-axis. This is the displacement. This is y. See, at this point, because of these two charges, electric field is 0. Electric field is 0 at this point, right? From there it is displaced. In such cases, force is directly proportional to displacement. Force is directly proportional to displacement. So we will be searching for this case. Force is inversely proportional to square of the distance, right? So this is inverse square law. This is different. Whatever may be the magnitudes, but in this case, force is directly proportional to displacement. Okay. Of course, by changing other parameters, we can get other answers. But in this case, it is proportional to y. Now let me exaggerate. Instead of writing small, let me make it a larger displacement. If Q by 2 is displaced and this is the position of Q by 2, there is repulsion between these two. Repulsion. This is force of repulsion. Repulsion between these two. Right? Now, resultant of these two will be along y-axis. This is reference line. If this angle is theta, then this angle is theta. Theta, then which is theta? This angle is theta. Corresponding angles. Then vertical component of this force, that is this component, F sin theta. Vertical component of this force, F sin theta. So resultant of these two F sin theta is the final force. So F dash equal to 2F sin theta. Okay. F is force between these two. F dash is the resultant force. Why am I not considering the x component? X component means this vector has x component. This vector also has x component. These two are equal and opposite. Get cancels. So once you know that it is this, so concentrate only on the one component, because other components will give 0. Now, using this, at least once, let us write the formula full. Okay. 2, force is between these two, constant, charge Q, that charge is Q by 2 divided by distance, this hypotenuse is root of, this is A, this is Y, A square plus Y square, under root. So A square plus Y square under root, there is root, right? Good. Into sin theta. This sin theta is, instead of this theta, let me go to this theta. Sin theta is opposite by hypotenuse, y by this. y by hypotenuse is again same thing, root of a square plus y square. Root means power half. Done. Now there is a catch. This displacement should be very small compared to this displacement, not just small. This is different, right? Y smaller than a, y much smaller than a. If y is much smaller than a, compared to a, means a square plus y square is approximately equal to y square. Sorry, a square. You can neglect y. Now, observe equation carefully. Denominator, you can neglect y compared to a. You can neglect y compared to a. Root square gone, a square, square root square gone, a. It is a square into a is a cube. So this is a cube into y. There is this y. What they are asking is relation between force and displacement. So there is no other y term. Therefore, F is proportional to y. This is another amazing problem on charge density. The region between two concentric spheres of radii A and B, A, B, two concentric spheres. Region means this region has volume charge density and it is not uniform. Volume charge density is not uniform. Once you know that volume charge density depends on some other parameter, you know how to solve, right? Please go to previous video and go through few cases, work out on few cases. This will be very easy. This becomes very easy. Okay, done. Now, at the center of this sphere, there is a charge. At the center of this sphere, there is a charge. The value of A, this A, such that electric field in the region between the spheres is constant. In this region, it is constant. Electric field is not constant because of rho, but because of Q, that electric field is constant. Okay. Now, let us understand step by step. Consider this point. Electric field at A due to this charge alone, because this charge density is outside. Gauss theorem says you have to consider charge within the surface, charge within the Gaussian surface. If this is the point, within this charge, within this Gaussian surface, there is only one charge. So electric field at A equal to constant, there is charge Q, this distance is A, so it is A square. Now come to this point. We have to find electric field at that point. Electric field at that point, EB, is equal to field due to charge, plus field due to charge density rho. So because of this charge density, there is some field. So resultant of these two gives EB, field at this point. Now let us find this first. Okay. As usual, consider a point which is at a distance r, keeping r as radius. Construct a sphere. Surface area of that sphere is 4 pi r square. After that, consider small thickness. So thickness of this is dr. Therefore volume is 4 pi r square into dr. Now, since charge density is mentioned, you know how to solve from charge density. So charge equal to integration of charge density into dV, right? Density is charge by volume, small charge by small volume. Therefore, dq is rho dV, rho dV. Q, dq to q means integration. Fine. Equals integration of rho is a by r. This dV is 4 pi r square into dr. Now observe dr. We want electric field from this point to this point at a distance a to b. So limits are from a to b. Hope you understood. We want between these two spheres. Right. Next. R. There is only one term r. Dr. We have to integrate with respect to r. R. Integration of r is r square by 2. R square by 2. Give upper limit b. So it is b square minus lower limit is a square by 2. So charge equal to, after integration, a 4 pi. A 4 pi. Integration gives b square minus a square by 2. So this is charge. Because of this charge, this is charge within this sphere. Because of this charge, the corresponding electric field is, recall application of Gauss theorem. Gauss theorem says electric field into area equal to charge, this charge, by epsilon naught. This charge is a 4 pi b square minus a square by 2 epsilon naught. Area of this red sphere 4 pi. So we want up to this point. So since we want an electric field at B, so 4 pi b square into electric field. Now carefully observe, 4 pi get cancels with 4 pi. Next, this electric field is a b square 2 epsilon naught b square, 2 epsilon naught b square. Numerator is a b square minus a square, a b square minus a square, a square. This is electric field due to charge density, rho. Now I want space. It's mentioned electric field is uniform. Electric field is uniform. Electric field is uniform means electric field in this region is uniform means electric field at A equal to electric field at B, means these two must be equal, right? Now EA equal to electric field at B, but electric field at A is only because of Q. Constant Q by distance is A square. Only one equation. But electric field at B, that's because of Q, this term, just like this. Constant charge is Q, distance is B square, plus at that point electric field because of this shell of thickness, this entire thickness, shell of this entire thickness. Okay, let me make it clear. Right, shell of this, or because of charge density, the electric field, that electric field is this, a b square minus a square by 2 epsilon naught b square. Now we have to solve for A, and here is A. Now carefully observe, Let me take this to the other side, this to this side, constant q 1 by a square minus this to the other side means 1 by b square equal to a b square minus a square by 2 epsilon naught b square. Carefully observe, they have arranged values or the parameters such a way that simplification should be easy. We are going in the right path means we get all the equations, required equations in between. See, b square minus a square, b square minus a square by a square b square. This is constant times q equal to a b square minus a square by 2 epsilon naught b square. See, automatically things are arranged. Just get cancels. Now this constant is 1 by 4 pi epsilon naught. 2 epsilon naught. This is 2 pi. Now we have to get expression for a. B square 2 epsilon naught gone. We have 2 pi q by 2 pi on the left hand side, a square equals on the right hand side there is a, there is only a. Oh, we got the answer, q by 2 pi a square. So with respect to concentric spheres, we will understand how to solve this problem, how to get electric field. Next, because of just distribution of charge, how to get electric field. Because of just a point charge, how to get electric field. Many concepts can be learned in this problem, from this problem. An electric dipole has a fixed dipole moment P, which makes an angle theta with respect to x-axis. Done. So with respect to x-axis, dipole makes some angle. When subjected to electric field, this electric field is along x-axis. It experiences torque. When subjected to another electric field along y-axis, it experiences torque, which is equal and opposite to this. Good. Now understand, x-axis, y-axis, z-axis. Let this be the dipole. Minus q plus q. What's the direction of dipole moment? It's from minus q to plus q along the line joining the charges, right? So this is p cap. This angle is theta. If a vector makes angle theta with respect to x-axis, we can write that vector in terms of components. Isn't it x component x into I plus y component into j cap. This x component is p cos theta into I cap p sin theta into j cap. Right. We understood one step. So a vector can be represented in terms of their components. Now, expression for torque is P cross E. Now let us first find torque due to electric field E1. So T1 equal to P cross E1. After that, T2 equal to P cross E2. They are equal and opposite. Let us substitute, we'll get the answer. Okay, done. Now, P is this entire equation. P cos theta I cap plus P sin theta j cap cross electric field. Electric field is E into I cap. And you know, I cap cross I cap is 0. So this term get cancels with this. Now this is this. Get cancels. It gives 0. Angle between x-axis and x-axis is 0. cross product when they are in the same direction, it is 0. Done. Now remaining P sin theta E. P E sin theta into J cross I. What is J cross I? It is minus K. I cross J is K. J cross I is minus K. So direction is minus K. So this is T1. Done. Similarly, we have to find T2. Torque T2. T2 is again this equation, P cos theta I cap plus P sin theta J cap cross second electric field is √3 times E1. E1 is E J cap. √3 E J cap. Now J. This cross with this means 0. This into this. √3 E P √3 E cos theta. I cross J is K. See, one is along positive z axis, the other one is along negative z axis. They must be equal and opposite. Yes, they are in opposite. Equal means we have to equate this to this. Done. Now let us solve that. PE sin theta, PE sin theta should be equal to this, √3 PE cos theta. Done. This is this, this is this. Equal in magnitude. PE gone, sin by cos, tan. So tan theta is √3, it is 60 degree. 60 degree. So in this problem, we'll get to learn how to use a vector in component form and then cross product of two vectors. Three charges Q, Q, Q are placed respectively at distances 0, d by 2 and this is d. Charges Q, Q and Q. Done. If the net force experienced by Q at x equal to 0, then value of Q. Done. This is one more standard problem. If these two are positive, this must be negative. So negative. And this is d by 2. So charge must be Q by 4. You will understand why it is 1 by 4 because of inverse square law. Okay, done. Because of this charge, force on this charge, positive, repulsion. This is the force of repulsion. Done. And this force is constant, product of the charges Q and Q by distance square. Distance between these two is d. D square equals. To nullify this, this should be negative charge, isn't it? If this is negative charge, then there will be attraction between these two. So this can hold this charge back. So this is the opposite force. And this force is between these two charges. Constant Q, 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 Q by d by 2. Distance between these two is d by 2 square. Now this should be equal to this. Constant Q, d square, d square. Now we have Q equal to Q into 2 square is 4. Therefore Q equal to Q by 4 with negative sign. We understood why it is with negative sign. Done. Therefore it is minus Q by 4. For a uniformly charged ring of radius r, electric field on the axis has the largest magnitude at distance h from its center. Then the value of h is. standard concept. If this is a ring of charge, electric field exactly at the center is 0. So electric field equal to 0. Done. This is the ring of charge, same. This is axis. At this point, electric field is 0. So with increase in distance, electric field increases, becomes maximum at distance h. So here electric field increases. Here electric field decreases. And we have to find h. And this h is r by root 2. So this looks like a conceptual question. No more variables, just h and the ring where it is maximum. Now, let us understand step by step. Let us consider small region. That length is dl. So lambda equal to total charge by total length. Total length is 2 pi r equals small charge on this length by small length dl. Small charge by small length. Okay, this is lambda. Next, because of this charge, electric field at this point is away if we consider this as positive. Okay, if the ring is positively charged, then the electric field is away. Let this be theta. If this is theta, we understood that only perpendicular component matters. So this component is E cos theta. So we have to find E cos theta. E cos theta. Integration of E cos theta gives total electric field E dash. Now, what is E? Integration of E is constant. This small charge is dq by this distance. Radius is r. This distance is h. This is hypotenuse. So this hypotenuse is r square plus h square under root it square. So this is actually a right angle triangle, right? And this angle is 90 degree. Good. Cos theta. Cos theta is, if this is theta, adjacent side by hypotenuse. Adjacent side is h. It is h by hypotenuse is again root of r square plus h square whole to the power of half. So this is the equation E dash. This dq, let us adjust here only. dq is lambda times dl. So dq is lambda times dl. What is integration of dl? Integration of dl is total length 2 pi r. So E dash equal to constant, denominator observe, r square plus h square whole to the power of 3 by 2. Numerator is lambda h into this dl is 2 pi r, total length. We have to find the point where electric field is maximum in terms of with respect to h. So differentiate this equation with respect to h and equate this to 0. Differentiate and equate this to 0. Okay, done. Now we have to differentiate this. Differentiate with respect to h, equate it to 0. Now how to differentiate? d E dash by dh equal to this constant lambda 2 pi r, lambda 2 pi r, h by this d by dh of h by r square plus h square whole to the power of 3 by 2 in terms of h equate this to 0. So this cannot be 0, this cannot be 0, let me drop this, lambda 2 pi r cannot be 0, drop this. So differentiate and then equate it to 0. It is ratio denominator r square plus h square whole to the power of 3 by 2 into derivative of the numerator 1 minus numerator into derivative of the denominator 3 by 2 r square plus h square. 3 by 2 minus 1 is 1 by 2 into differentiate h square 2h by denominator square r square plus h square whole to the power of 3 by 2, its square 3. Now in this, let us take r square plus h square 3 by 2 common factor. R square plus h square whole to the power of 3 by 2. This is 1 minus 2 to 3h square, 3h square. There is 1 by 2. So multiply and divide this by r square plus h square, r square plus h square. So this comes out. Remaining is r square plus h square. Denominator is r square plus h square. This whole divided by r square plus h square whole cube equal to 0. See, product of this says this cannot be 0. Drop this. This cannot be 0. Drop this. So equate this to 0. Equate this to 0. One minus 3h square by r square plus h square equal to 0. Bring it to this side. 3h square by r square plus h square equal to 1. 3h square, just rearrange, you'll get r square plus h square. 2h square is r square. So h equal to r by root 2. H equal to r by root 2. Students, don't forget to check the link in the description box. There is a surprise. You will find PYQ of CET in physics of all the question papers from past 15 to 17 years. You will learn shortcuts, explanation, everything. Don't forget, check the description box. Good luck.